To start off section 4.2, we're going to do an activity that addresses learning objectives A and D. So we're going to understand what cosine and sine represent on a unit circle, and we're going to use the calculator to approximate values of sine and cosine in radians and degree mode. So let's get started with the activity. Now the first thing I want us to do is figure out where cosine and sine come from. If we take a look at this unit circle, because the radius is 1, that's been superimposed on Algebra 2 graph paper with the XY axis. Let me ask you this. If I wanted to know how do you get to this point right here on the circle, you could tell someone to do some basic coordinate movements. Now what you probably tell them is to move over. If this is all the way to 1, then every tick mark is a tenth. So that's 1, 2, 3, 4, 5, 6, about 7 tenths. So you'd move right about 7 tenths, and you would move up. It looks like we're going another 7 tenths. Therefore, this would be the ordered pair, 0.7 and 0.7. So what that means is if I wanted to move this angle movement and land on the circle right here at the ordered pair 0.7, 0.7, that would represent this particular angle movement, whatever it is. And we call that angle movement theta. Now, we all would agree that this movement is the x movement to the right and the y movement up, so I'm going to call this the x and the y for now. And then I'll also label this length right here as the x movement, and this length right here is the y movement. Now notice this right triangle has been superimposed on the graph paper, and it's embedded exactly in the unit circle. So let's talk about some geometry ratios, tangent, sine, and cosine. Hopefully you remember from geometry the SOHCAHTOA acronym. If not, you'll want to. And tangent, therefore, is the TOA component. So if I asked you what is the tangent of this theta or this angle, we would say it is opposite over adjacent. And in this case, if we look at the angle which is here, the opposite side is y, the adjacent is x, so it is y over x. Okay, let's do sine. The sine of the angle, so sine is SO, which is opposite over hypotenuse. So in this case, the opposite side on this angle is the y. And then the hypotenuse is right here. Well, we actually know what the hypotenuse is on this triangle. Keep in mind, it's embedded in a unit circle that has a radius of 1. Well, if this radius is 1, so is this. So the length of our hypotenuse is 1. So what I can do is I can say sine is opposite over hypotenuse, or it is the y over 1, or it equals y. So what we just defined is this. We just said the y movement equals sine. So I'm going to come back up over here, and in my ordered pairs, I just said y is the sine of the angle. Well, let's continue on to the cosine. Cosine is ca, or adjacent over hypotenuse. So the angle that's adjacent, or the side from here, is x. The hypotenuse is 1. So cosine, let's just write adjacent over hypotenuse. And the adjacent, again, was the x. The hypotenuse is 1. And what this says is that x actually equals the cosine. So I'm going to go up here to the x value and change it to the cosine of the angle. So what this did is it actually now has changed our Algebra 2 graphing paper of saying x and y to graph things to actually now we're going to say this. This x-axis is the cosine of theta. The y-axis is the sine. And what that allows us to do is to figure out for any angle movement what ordered pair would be on the circle. For example, if I said if I moved 100 degrees from here, 100 degrees might land me about right here. If I wanted to know what that ordered pair movement was, and again this was 100 degrees, all I would have to do is this. That theta means the angle. So you would do the cosine of 100 degrees and the sine of 100 degrees, like this. And what that'll kick back, I'm going to use my calculator, it's going to give me some ordered pairs. Or we can estimate it by looking at our graph paper right now. It looks like we're going to go about left 1, 2, 3, so 3/10 left, so that'll be negative 0.3. And the sign or the y value on this looks like we're going up to a little bit over 0.9 even. I'm just going to estimate 0.92. And I'm not exactly right, but it's an estimation. So what that means is if I want to land at 100 degrees on a unit circle, I know that the x movement, or in this case the cosine, is the cosine of 100 degrees, which is approximately negative 0.3. And I know the up movement to graph this. The up movement is my y, so the sine of 100 degrees is about 0.92. So the cosine at 100 is this, and the sine at 100 is this. So let's just use that concept for this activity. We're going to derive the actual unit circle. And in this section, we just do approximate values. So what we're going to do is really just focus on steps 1 and 2. We're going to use the calculator and find the corresponding coordinates for all degrees and radian measurements. And then we're going to complete the unit circle. So let me show you how it works. So remember, we talked about if we're on the unit circle, which is right here, and let's say we wanted to move 60 degrees, for example. So if I move 60 degrees, it'd be approximately maybe right there. Now, what are the ordered pairs of this 60 degrees? To find out what that ordered pair is, all I would do is the cosine of 60 degrees in my calculator and the sine of 60 degrees in my calculator. And when I do that, I'm going to put the values right here. Now remember, we said if we were to graph this, we would go to the right, and that x-axis is now called cosine. The up movement is the y, and that is called the sine. Now, you need to go to your calculator and type in the cosine of 60 and the sine of 60 degrees. And you want to make sure when you do the cosine of 60, what you should get is 0.5. For the sine, it's going to be 0.866 as we round. Now, if you do not get those numbers, it means your calculator is not in the right mode. Look for the mode button on your calculator, select it, and for this one, what are we dealing with? Here we're dealing with degrees, so you need to make sure that you're in degree mode. So you need to go through, make sure your calculator is in the degree mode, and then you are going to type in values for every single space here. You're going to find all the cosine and all the sine values for these various degree movements. So go ahead and find these values and see what you get. Now the first thing you should notice, this right here is just quadrant 1. From 0 to 90 degrees is what I figured out right here. And notice the values, make sure that you're getting the appropriate and the same values that I have listed here. Now when we go to 120 up to 180, this right here is going to be quadrant 2. So move into quadrant 2 and let's see what you get. Okay, these are our quadrant 2 values. And if we separate this out, we're now in this quadrant 2. Notice the pattern that's happening. You're going to start seeing these numbers are being repeated. But remember, anything over here in quadrant 2 to graph, I have to go left and up. In quadrant 1, it was right and up. Now, the up movements on a unit circle are the sines. So you're going to notice these sine values are the same. But the right and the left movement indicates cosine. Notice what happens. In quadrant 1, they're positive. In quadrant 2, they're going to be negative. But they are the same values, but different signs. Let's go into quadrant 3. Now in quadrant 3, to graph anything down here, we have to go left and down. Left means cosines are negative, down means sines are negative. Everything here are double negatives, but they're just replications of these same values. And then the last quadrant, in quadrant 4, we're going to get the values such that what happens is the sine values are negative. Because here in quadrant 4, the x movement or cosine is positive, the sine movement or the y movement is negative. So all the signs are negative. Now this activity is going to challenge you to say, okay, now switch on your calculator, go to the mode again. In this time on the mode, choose the radian mode. And here's how you know why. If you look at these are pieces of pies. These aren't degrees. Whenever you use the sine, cosine, or tangent button on your calculator, the mode must be checked. Those are the only buttons on the calculator that read the mode value. So if you're typing in pies, you must be in radian mode. Now, as you start to type these in to the calculator, for example, let's say you did pi over 4. If you did cosine of pi over 4 and sine of pi over 4, literally go cosine, find the button of pi, and do divided by 4. You're going to get 0.707 for cosine and 0.707 for sine. Well, that actually relates to one of the degrees. Well, what degree happens at pi over 4? Well, if you want to convert it, remember to convert radians to degrees. You can just change pi to 180. So 180 divided by 4 is 45 degrees. So pi over 4 for the radians is the same ordered pair as 45 degrees. You are going to find every single one of these radians will match up with a corresponding degree. After you do this, let's put together the complete unit circle on the next page. Now, what you're going to want to get comfortable with are 4 things. You want to go ahead and draw 1 degree. So I'm going to do a radian, and I'm going to say this is a 0 degree movement. That is 0 pieces of pi. Now, what ordered pair got me at that? It's 1, 0. Now remember, what does the x value mean on this graph paper? X is the cosine of an angle. What does sine or y mean? Y is the sine of an angle. So this ordered pair here tells a lot of information. This ordered pair says if I move 0 degrees or 0 pieces of pi, the cosine of that will be 1 and the sine of that angle will be 0. Now the next angle measurement is 30 degrees. So what you need to do is write the degrees for 30. Now what piece of pi is that? Look and see which one matches it. It's pi over 6 radians. What's the ordered pair here? It's 0.866 and 0.5. Again, what that means is that if someone said, what's the cosine of 30 degrees? I'd say it's 0.866. If I said, what's the sine of pi over 6? It's 0.5. You're going to do this for the entire circle. And here's what quadrant 1 looks like. Now, as you put together the other quadrants, remember all the numbers were the same, but they were different signs. So there's a really great connection. I'm going to have you watch me do 30 degrees. If I go straight across, the reflection of 30 degrees is going to be there. If I go down, and if I go here. So all 4 of these are going to be the same numbers, but different signs. To get at 30 degrees, I had to move over 0.866 and up 1/2. So I moved right and up. Now to go over here, I'd have to go left and up. So the left and up movement is going to be negative 0.866 and then 0.5. Now, what degree in what radian is that? It's going to be 150 degrees, which is the same as 5 pi over 6. Now if I move down over here in quadrant 3, it was a left and down movement, so everything here is a negative, and that's a negative 0.5. The radians and the degrees for this is 210 degrees, and this is going to be at 7 pi over 6. And then the last one over here is going to be a positive right movement and a down movement. And this one happens at 330 degrees or 11 pi over 6. Now the other angles are connected in a similar fashion. The 45 degrees, if we take this and just go straight across, 4 of these are related, and let me fill them in. And here's what all the pi over 4 measurements look like. They're all going to have 0.707 on the x and the y, or the cosine and the sine, but the values are either positive or negative. Now let's look at the pi over 3's. If we go straight across, then down here, and we find the values, here's what we'll get. Again, you're going to notice they're the same numbers, but the signs change. And then the last ones we should fill in are when we cross on the x and the y axes right here. This here we know is 180 degrees. That's one piece of pi. This is the ordered pair -1, 0. This one down here, this is going to be 270 degrees. It's 3 pi over 2. And this is the ordered pair 0, -1. So with this, we have tons of information about all these various angles. One thing you might want to do to help you see the angle better too is actually draw the rays that go and make all these angle movements. You can see that connection a lot better. So if someone said, hey, what if I go around the circle and I move 225 degrees? Well, from here, I always start. If I move 225 degrees, I land right on this ray. What do I know about 225 degrees? Well, I know the cosine is -0.707 and the sine is -0.707.